Ladies and gentlemen, welcome to the online masterclass, How to Ensure Safety for Emerging Green Hydrogen Applications. My name is Honem Shah, and I'm a Senior Content Analyst from Leader Associates. And I'm thrilled to be hosting this masterclass, which is part of our digital content for the upcoming event, Connecting Green Hydrogen APEC 2023. Taking place from July 25 and July 26 at the Melbourne Convention and Exhibition Center. This event serves as a premium platform for the industry professionals to gather and exchange knowledge about the latest advancements in green hydrogen. Amidst this contest, our masterclass aims to shed light on the crucial aspect of safety, ensuring that growing potential of hydrogen is accompanied by a comprehensive understanding of the risk involved. As the world witnesses significant roles in adoption of hydrogen across various industries, it becomes prominent that we understand the potential hazards associated with this field and implement robust safety measures. At this masterclass, we also honored to have Mr. Claudio Faccarotto, the Business Development Managers at MSA Safety, as our keynote speaker. With his vast expertise in this field, Mr. Faccarotto brings valuable insights into the discussion of hydrogen safety measures and detection technologies. Through this masterclass, we'll dive into key topics to equip this industry with essential knowledges. We'll also explore the challenges and the risks associated with hydrogen, emphasizing its unique property as combustible gas. Furthermore, we'll also dive into the world of leak, gas, and flame detection technologies, understanding their crucial role in maintaining safety within hydrogen applications. Lastly, we'll introduce the concept of the protection layer, providing a comprehensive understanding of how these technologies come together to ensure a secure hydrogen plant environment. Now, without further ado, let's welcome Claudio on stage. Claudio, please start your masterclass.
Thank you very much, Olman, and thank you, everyone. It was a pleasure for me even be part of this masterclass section. And here we go, sharing my screen. Hello, everyone. Again, what Olman say is that we are talking about a very interesting topic in terms of safety for green hydrogen applications. And that is an interesting topic where MSA wants even to deliver a message that the right usage of the right technology will be able to make safe any kind of a green hydrogen application at your plant. First of all, we are talking about the challenge and risk, and as we started in the introduction, hydrogen is something that is not new on the market. So hydrogen is a molecule that we know since many decades. Is a propensity to leak. Why? Is small. We know that is the smallest molecular we know so far. Is extremely high diffusivity. That is the major reason why is able to leak very quick. Propensity to ignite is one of the molecular that easy to explode with a very low energy, with a fast detonation and wide flammability range. The consequence of that, it will be an invisible flame when fed by even 100% of volume hydrogen with low thermal radiation and high flame temperature, which means that a potential injury of life can be happen at any time due to the fact that it's not possible to see the flame at any time or even present in a path where the people are working. That is our internal study in terms of fluid dynamic leakage under different pressure. You see also a wind direction that is a very low speed of wind, and you can even understand that compressed gases, compressed hydrogen is in some case unlikely to predict the direction. What that means is that the weather condition or even the pressure are conditioning the way and the direction or even the shape of the cloud. You can see the red line at a certain point with 100 bars can reach up to 7 meters down on the ground. So we have to say that it will be quite complicated to even admit that hydrogen will go up. Let's think about that, even how to solve this issue. First of all, what is the scope of the gas and flame detection? Especially for the gas detection, which is the first defense in terms of safety, is the early alarming that will help to avoid any dangerous situation on your side. So we are talking to protect before that the condition become flammable and explosive. So for hydrogen, we are talking about 4% volume in atmosphere. So that is our scope, to keep the level of, or to even trigger the safety system at a certain early time in order to avoid that it become very dangerous. How we can detect the hydrogen leakage and which type of sequence we have to consider in order to be very efficient to avoid a potential worst scenario. If we consider these graphs, is the event tree for hydrogen gas release. So we see that at the first column on the left, gas is released. So we have the leakage. On the right, you see the cross light, which started to give you a sense of dangerous, which we will see then in the next slide in terms of recognition of the risk, and then how to which technology is able to detect it at that stage. When the gas is released, and there is a technology called the ultrasonic gas leak detection. In this case, we are able to stop immediately the potential risk because we are detecting at the speed of sound. Immediate injection is the time where we have to avoid. Otherwise, it become yellow, so become more dangerous because there is a more potential risk to become a cloud formation in a specific zone. Remember, the fluid, it can go in a different way. In this case, conventional gas detection will be useful to be in place because that might be a potential resolution in order to avoid the last catastrophic with the flame and explosion, which only the flame detector is able to detect in a condition where it's too late even to protect the asset. Go back to the technology. When we are talking about the green stage, the cross light is saying to us, if we detect with at the speed of sound, there is only one technology able to detect in this way. We are talking about ultrasound technology. Is not affected by the wind, is just hearing the sound. This, if you recall, every leakage is generating sound. How does it work? The generation of sound, we just cut the ultrasound level. So everything that is in the human hearing range, we don't care. We just cut off. And using this frequency from between 25 kilohertz up to 70 kilohertz, there is a ENN, artificial neural network, able to recognize with a combination of algorithm what is happening in this band, where come from the noise or the sounds, in order to recognize that is a leakage or even is coming from different type of source, which might be a false alarm. So with the ENN, that is the easiest way to even recognize between real leakage and the background noise. Second protection layer. So that is based on conventional gas detector. We are talking when the leaking gas is already in a cloud form. The only option here is that it operates must make sure that it detects before other propagates in the right position. So we have to wait that the clouds is eating. That is the unknown time that it will take. That's why it's become yellow, the conventional gas detector. How does it work? We are talking about point catalytic bit gas detection. The graphics, the infographics is telling you is based on two elements. we call a bead pellistor. One is a compensator, the second is a detector. They are built in a Wilson bridge, and when the hydrogen is hitting the sensor, there is a chemical and physical reaction which will unbalance the Wilson bridge in terms of millivolt, and then we get the signal, and then we know what is happening in terms of LEL percent concentration. That has to be very stable. That's why MSA is using this technology with a specific design, because it's very important, because it's the last resource in detecting the leakage when is forming a cloud base. There is also another technology called electrochemical. It works like a battery with inside an electrolyte that is reacting when hydrogen is hitting the sensor. So the consequence is that we have the option to monitor or to detect the ppm range rather than the percent LEL. ppm is up to 1000. It's very sensible. So that is a technology that is recommended to be used when is needed to detect at the very early stage in a ppm, so a very small molecule. Last protection layer is when become flame. That is the most dangerous situation. Anyway, we need to have the appropriate technology to detect the flame. How does it work? MSA is using the combination of ultraviolet and infrared sensor, because the two types of sensor are able to see the emission of the hydrogen radiation, which is in this case is clear is a 295 micro. Let's recall that for the hydrocarbon flame, we are talking close to 4 micro, which is completely different. That's why we are able to see the transparent and invisible flame from hydrogen. Why do we use ultraviolet sensor as well? Because in this case, the combination of the two sensors is able to avoid any false alarm coming from a source generating ultraviolet even radiation. The combination of two is giving a detector able to see the flammable flame from hydrogen, wide coverage of area. It works like our eyes, so it's seeing the flame at a very early stage. So the combination of the three technology are making what we call the protection layer. Is a combination of linked to the three human sense: hearing, smelling, and seeing. The combination of the three layers, the three technology, is able to give the complete package of safety concept. Also very efficient, because we can detect from early stage up to when generated flame, and that is probably very important that those three technology works together. So if you recall the first slides with the simulation of the propagation of the leakage under a certain pressure, you can imagine now understanding the three technology that's having on your plant that will be able to protect your asset and your people against any possible worst scenario generated by the emission of or leakage of hydrogen and potential explosion. With our three technology, we are answering to the main question about influence of weather or wind direction. So with the ultrasonic gas detector, we can detect hearing the sound of the leakage. With a conventional gas detector, catalytic and electrochemical, we can focus to detect close to the point. Look on the pictures. And the third protection layer is based on the flame, which is the last stage when the potential leakage become a flame, which I hope that will never happen. In this graph, you can see that the ultrasonic gas detector is able to cover up to 27 radius meter per 360 degrees. So that will be really, really interesting to cover a wide range of your plant. A safety chain architecture is based on the combination of the three elements, the three sensors with an MSA controller, and then you can trigger the safety solution like shut down the voltage or even initiate the ventilation, depending on the application. Remember that every case is very specific. That is just the overview of the technology of our products. I will invite you to visit our booth at H14 in the Connecting Grid Hydrogen APEC 2023 in July from 25 to 26. And our technicians are there to explain and show you our products. Thank you very much.
Claudio, thank you so much for presenting such an informative and thought-provoking class on the safety measures for the growing hydrogen industry. And I think our audience will definitely gain deeper and more professional insights into the current challenges and risk of the hydrogen technologies, protection layer concept, as well as the cutting-edge leak and flame detection technologies that has been developed by the industry and MSA. And I very much look forward to learning more about this at our in-person event, Connecting Green Hydrogen APEC on July 25 and July 26 in Melbourne this July. And during your masterclass, I also have some really interesting questions that I'm personally curious, and I hope you could further explain and specify for me and for our audience who are watching this masterclass. So first of all, can you explain when cat bead or electrochemical sensors should be used for the point detectors?
Yeah, that is a good question. Based on the very simple explanation of the two technologies, they can detect at a specific concentration of the leakage. We are talking about if we start in a very small leakage in ppm, part per million, it's better to use an electrochemical technology because it's able to detect up to 1000 ppm. After this one, if the sensibility is not really required, is better also to use the cat bead because we are just looking and detecting what is the 100% LDL, the lowest explosive limits or lowest flammable limits. The application might be the same positioning. The only thing is that the sensibility is more on the electrochemical rather than the cat bead. But it's always specific for the application to identify which are the best one.
Okay, thank you, Claudio. My second question is, why do you think the ultrasonic detection is better than the other technologies that you mentioned in your presentation?
Yeah, also a good question. We don't say that the ultrasonic is better than other conventional technologies. It depends on the application and the situation that we are. For sure, the technology can work better than others, but the different technology is a combination and make the complete package of defense in terms of safety. Ultrasonic is able to work when is a plant under the effect of wind. So weather condition can affect the direction of the leakage. And the conventional gas detector is more suggested to be installed in appropriate points where is expected the risk of leakage, like a flange, connection, skid. So it's a more local, is more targeting the possible leakage rather than the ultrasonic is able to hear in a wide range, in a wide area, which is more affected by weather conditions. So the combination of the two is the best class option in order to have the best solution in monitoring or detecting the leakage.
Thank you, Claudio. And I'm also wondering why, the combined UV or IR technology should be used for H2 flame detection. And that's the part I'm also curious about.
Yeah, that is something already mentioned in the presentation. Remember, the slide has the two sensor. MSA believes that using two different sensor technology, the ultraviolet and the infrared, the combination is reducing the effect from false alarm. If you think like the sun ray, standard lights can affect a detector recognizing like a flame. In this case, with an algorithm in the software, we are combining the two sensors in order to avoid this very annoying false alarm that can even shut down the plant. And our scope is to keep the safety, but also to maintain a certain reliability of the system, and we have to avoid the false alarm. That is our philosophy using the ultraviolet and infrared technology in one flame detection.
Thank you, Claudio. And my last question for you is there any general guidance for like positioning and the quantity of detectors? For example, for the 20 square meter, we should have the X numbers of detectors.
That is a great question. We have to consider that for the time being, there is no a specific regulation that is stating what is the coverage of a gas detector or a flame detector. Well, with a flame detector, we know that is a coverage in terms of optical view. And for the gas detector, we have to identify this is a specific, is a project specific, the allocation of the detection. For sure, there are today in 2023 a sophisticated software that can make a gas and flame mapping, which is also able to determine the position and the location of the optimal position of the gas and flame detection. So our recommendation is, well, the first design of the system is always better to be done. But then a possible approach is to use the gas and flame mapping in order to recognize the right positioning and the quantity of detectors.
Okay, Claudio, thanks again for all of your really detailed and professional answers to these questions. And I also look forward to witness the innovation of more like effective safety measures and systems that will be put in place to ramp up the production of green hydrogen globally. And I just can't wait to learn more about MSA's hydrogen safety measures on the morning of July 26th at our physical events, where you will probably be delivering an keynote speech.
Thank you very much.
Thank you, Claudio. And
Thank you.
last but not least, I would like to thank our audience who has watched it here, and hope you find this masterclass useful and insightful. And you could also download the presentation slides by submitting your information to review the whole content of this page, as well as the key takeaways of this webinar. And please stay tuned for our upcoming digital series as well. See you next.